Tonight, while you sleep, water is forming on every cold surface outside your home. Millions of liters, every night, everywhere. It collects, rolls off, and disappears into the ground. You could have been capturing it for $12. Clean water, cleaner than you'd expect. No subscription, no utility bill, no infrastructure required, and almost nobody uses it. Welcome to Survive Better. Let's open the vault. Hit subscribe and the bell if you are not already in. The oldest evidence starts in the Negev Desert, where Bronze Age builders left no written record of what they understood. Researchers examining their stone cairn formations, studied in depth by Michael Evanari and colleagues in their 1982 work on Negev water systems, found structures positioned at specific angles to prevailing night winds, with base channels that would have directed condensed water downhill into collection points below. These were not graves, they were not shelters, they were water machines. The geometry speaks clearly enough. 1,500 years later and several thousand miles away, high in the coastal range above the Atacama Desert in what is now northern Chile, the Inca engineers responsible for supplying outlying settlements faced a problem with no obvious solution. The wells had been dry for 2 seasons. The nearest river was 3 days of walking in either direction. Rainfall in that zone averages less than a single millimeter per year. By every conventional measure, those settlements should not have survived. And yet they did. Archaeological surveys found stacked stone structures built on the exposed ridgelines, not to hold water, but to produce it. The stones were arranged at specific angles to the prevailing wind, with channels carved below each formation leading downhill into ceramic collection vessels. Their surfaces showed centuries of mineral deposits, consistent with repeated condensation and evaporation. They were not cisterns, they were fog catchers. The cold stone dropped below the dew point of the humid coastal air rolling in overnight from the Pacific, and every morning, without any human effort, water appeared where there should have been none. The Inca did not name the process. They built for what they had observed to be true. 2 centuries after that, on the other side of the world, in the highlands of the Canary Islands, the indigenous Guanche people of El Hierro had a tree. They called it the garwe, a species of laurel that grew at an elevation where Atlantic fog rolled through every night. Its broad leaves collected condensation so efficiently that Spanish colonial administrators, whose accounts José de Vieira y Clavijo compiled in his 1772 historical record of the islands, documented it as the primary water source for the island's population during dry seasons. When the original tree was destroyed in a storm, the loss was treated not as a natural event, but as an infrastructure failure. A replacement was eventually identified. The system continued. And then, like everything in this story, it was filed away as a curiosity of natural history rather than a lesson worth keeping. 3 civilizations, 3 continents, no contact between them. The same answer arrived at independently, built with local materials, sustained for generations. That is not coincidence. That is physics working the same way it always has, and human beings smart enough to notice. In 1986, Dr. Robert Schemenauer, an atmospheric scientist at the Meteorological Service of Canada, began what he described as a practical field study with no expectation of transformative results. He and his colleague Pilar Cerceda set up large-scale mesh panels on the fog-shrouded ridges above Chungungo, a fishing village on the Chilean coast where the municipal water supply had collapsed. The panels were standard polypropylene shade cloth, stretched over simple frames, angled into the prevailing wind. What they measured, quietly, rewrote what applied hydrology considered possible. The mechanism works because of a physical threshold called the dew point, the temperature at which air can no longer hold the water vapor suspended within it. When humid or fog-laden air contacts a surface at or below that threshold, the vapor releases as liquid. Mesh is the ideal collection medium because it maximizes surface contact without blocking airflow. A solid wall deflects fog. A mesh panel lets it pass through while forcing contact with thousands of individual fibers simultaneously, each one collecting droplets that merge, grow heavy, and roll downhill by gravity into a collection trough below. No moving parts, no power source. The atmosphere does the work, and the mesh intercepts the result. The Wuppertal Institute's 2001 review confirmed that properly positioned collectors in moderate humidity environments consistently produced between 3 and 12 liters per square meter per day. That range covers everything from a family's daily drinking water to agricultural supplementation. Commercial atmospheric water generators on the market today use compressors, refrigerant coils, and electric fans to force the same condensation process at a retail price starting at $2,000 and climbing to over $10,000 for household-scale units. The mesh does it for $12 and uses no electricity at all. Most people walk past this solution every single day without any idea what it can do. The ones who find out tend to make sure the people they care about find out too. And here is where it gets interesting. This never became mainstream, not because it doesn't work, but because there is no real business behind it. So why is this not on the shelf of every hardware store and emergency preparedness retailer in America? Here is what a $280 billion industry looks like. Nestle Waters, Danone, Evian, Volvic, PepsiCo, Aquafina, Coca-Cola, Dasani, Primo Water Corporation, Blue Triton brands. You cannot patent mesh. You cannot trademark condensation. You cannot build a subscription around dew point physics. You cannot charge recurring fees for wind and cold air and gravity. The atmospheric water collection model produces a one-time purchase and then produces indefinitely. Zero ongoing cost to the user and zero ongoing revenue to any company. That is not a business model any publicly traded corporation can take to its shareholders. The bottled water industry's economics depend on one belief, that water is something that must be purchased repeatedly from a controlled source. The moment that belief shifts, the recurring revenue model does not disrupt. It breaks. What Schemenauer documented in 1986 was a proof of concept for a water supply that requires no infrastructure, no utility relationship, no monthly bill, and no brand. There is no regulatory barrier preventing anyone from building a dew collector. No license, no permit, no professional required. The industry's protection against this knowledge is not legislative. It is informational. Keep it out of the mainstream conversation, and most people will never think to look for it. That is not oversight. That is architecture, deliberate and sustained. Now, here's exactly what to do with atmospheric water collection. Source your materials in a single hardware store run. Shade cloth mesh, the tight weave polypropylene kind, sold in the garden section, not the loose volleyball net weave, runs about $5 for a 6x6 foot section. 4 sections of 1-inch PVC pipe to build a rectangular frame, roughly 4 feet tall by 3 feet wide, will cost $2 or less. The standard plastic gutter section for the collection trough runs $3 to $4. Total, $10 to $14. Build the frame. 4 PVC sections into a rectangle, zip tied at the corners, no fittings required. Stretch the mesh over the frame and pull it, drum tight. Zero sag. Zip tie every 6 inches along every edge. Sag means pooling, and pooling means reduced collection. Tilt the finished panel at 15 to 30 degrees, leaning against a wall at a shallow angle, not flat on the ground. Flat is the single most common mistake. The angle means every droplet rolls downhill by gravity and falls into the gutter trough, waiting at the lower edge. Face the panel into the prevailing wind. Walk your yard at dusk, feel the breeze, point the front of the frame at it. Elevate the base at least 1 foot off the ground. Air near the ground is warmer and drier. Position the panel away from wherever the morning sun hits first, so the full night's collection is still in the trough when you come out at dawn. Watch for visible droplets forming on the mesh within the first hour after sunset on a moderately humid night. That is the process working. If you see no results after a full overnight run, check 3 things. The mesh weave may be too loose, the panel may be facing parallel to the wind rather than into it, or overnight temperatures may not be dropping far enough below the dew point in your location. Coastal and river valley sites perform significantly better than arid inland areas. For maximum safety, filter all collected water before drinking. Cut the bottom from a plastic bottle, invert it so the neck points down, and layer inside it, from bottom to top, cotton, activated charcoal from any aquarium store, fine sand, and a final cotton layer. Pour your collected water through from the top. 1 drop of plain, unscented household bleach per liter, 30 minutes of wait time, and it is as clean as treated tap water. $12, 1 afternoon, 1 hardware store run. A commercial atmospheric water generator costs $2,000 to $10,000 and draws continuous electricity. The physics is identical. The naked builders understood it 3,000 years ago. The Inca built for it 6 centuries ago. Robert Schemenauer proved it in a peer-reviewed journal in 1994. A $280 billion industry has spent the decades since ensuring that the $12 version of that same solution remained a footnote in atmospheric science journals, rather than a project anyone builds on a Saturday afternoon. This knowledge did not disappear. Someone made sure it stayed buried. Drop a comment. What else do you think got buried the same way? What did you have to find yourself that no one ever taught you? If this video opened something for you, subscribe now. The next vault opens soon. What is inside is even heavier than this.